Red alarm, year 2025. JPL Control Center breaths, hold. Because 25 billion kilometers away, battling the relentless waves of the interstellar ocean, humanity's greatest achievement is Voyager 1. Systems on red alarm. For almost 50 years, this iron-willed traveler has passed the universe's toughest tests. It has survived giant planets and solar storms. But now, an unseen enemy, an internal weakness, is about to bury it in silence. If it can't turn its antenna to Earth, if that vital line of communication breaks, it's game over. Humanity's hand reaching for the stars is lost forever in the void. Is this Voyager 1's final battle? Or will this metallic hero once again overcome a fatal malfunction with engineering genius and continue to send a message of hope to humanity? Voyager 1's ability to talk to Earth depends on pointing its massive high-gain antenna at our planet with millimeter precision. This aiming is accomplished with small but vital thrusters. Like a ship's rudder, they control the spacecraft's position, that is, its rotation on the pitch, yaw, and roll axis. In particular, roll control is vital. It rotates Voyager like a giant plaque locked onto a distant guide star, keeping the antenna pointing toward Earth. They had a primary and backup set of thrusters for this mission. But in 2004, disaster struck. Two small internal heaters that were supposed to warm the primary roll thrusters failed. In the freezing cold, the thrusters became inoperable, frozen solid. The engineers at NASA JPL at the time said, "No problem, the spares are intact." As Kareem Badoutin, Voyager mission manager, said, "Frankly, they didn't think Voyagers would go another 20 years. But Voyager proved them wrong. That stubborn explorer persevered for another 20 years. And now, in 2025, those reliable backup roll thrusters are beginning to sound the alarm. Years of fatigue, sludge accumulating in the fuel lines, were slowly clogging the thrusters. Like an old warrior with clogged arteries. Without roll control, Voyager's antenna would veer off target, and communications with Earth would be lost. It would be the end of the mission. Complete silence. And the nightmare didn't end there. A giant communications blackout loomed on the horizon. From May 2025 to February 2026, Deep Space Station 43, DSS-43, in Canberra, Australia, the only Earth antenna capable of sending commands to Voyager, would undergo months of maintenance. This tied NASA's hands. If the backup thrusters failed completely during this maintenance, there would be no way to send a cry for help to Voyager. Time was running out inexorably. The engineering geniuses at JPL had run out of options. Desperation was at the door. But giving up was not in their book. A plan, previously labeled impossible, was put on the table. Resurrect those primary roll thrusters that had frozen to death in 2004. It seemed like madness, but there was a theory. Perhaps the failure in 2004 was not irreparable damage. Perhaps a simple electrical glitch had turned off the power switch for the heaters that kept the thrusters warm. If this theory is correct, a clever command from Earth could have turned that switch on again. But this operation carried enormous risks. If the heaters failed, and the frozen thrusters were attempted to ignite, even a small explosion could wreck Voyager in that distance. Moreover, if Voyager's star tracking system deviated too far from its guide star during this delicate maneuver, the ship's autonomous software could have fired the still frozen, dormant thrusters on its own. The result was the same: disaster. For the crew, every second counted. Sleepless nights, feverish calculations, countless simulations. The Star Chaser had to be precisely aligned. The heaters gradually heated, and the commands perfectly timed. This was cosmic surgery, and there was no room for error. March 20th, 2025. A deep silence reigned in the JPL control room anxiety and hope mingled on faces. That critical command sequence was on its way into deep space. It would take 23 hours to reach Voyager, and another 23 hours for Voyager's response to return to Earth. A total of 46 hours of nerve-wracking waiting. At the moment the crew sent the commands, they were actually waiting for the outcome of an event that had happened about a day earlier. Even time flowed differently at that distance. The hours were not fitting into minutes, and the minutes into seconds. Everyone's eyes were on the data screens. And then, the moment arrived. The data began to flow to Earth. There was movement on the screens. First a flicker, then a graph came to life. A graph showing the temperature of the thruster heaters. It was rising. It was rising fast. It meant one thing: the heaters had worked. In the control room, there was first a gasp of surprise, then a deafening shout of joy. "It was such a glorious moment," said Todd Barber, the Voyager mission's propulsion system leader. These thrusters had been declared dead, and that was a legitimate conclusion. It was just that one of our engineers had a hunch that maybe there was another possible cause and it could be fixed. This was another miraculous salvation for Voyager. This incredible resurrection of the primary roll thrusters had given Voyager 1 a new lease of life. Engineers now had a robust alternative that they could deploy if the existing backup thrusters failed completely. More importantly, the steering control critical to maintaining communication with Earth as Voyager traveled through the interstellar medium was secured. And this was not Voyager's only recent success. In April 2024, after a 5-month data blackout due to a faulty memory chip, Voyager 1 began sending usable engineering data again. By May 2024, all 4 of its scientific instruments were back online, sending back invaluable information from the edge of the heliosphere. In February 2025, NASA shut down the cosmic ray subsystem to conserve energy and reserve power for other key instruments. These were strategic moves calculated to take the mission into the 2030s and beyond. What Voyager 1 continues to observe is of enormous scientific value. It is measuring the density, temperature, and magnetic field strength of interstellar plasma, data that no other spacecraft can currently provide. Its findings are shaping our understanding of the Sun's influence on the space environment around it, and helping us define the true boundary between our solar system and the rest of the galaxy. What's more, this mission serves as a testing ground for future interstellar probes. Its endurance is inspiring the design of spacecraft intended to leave the solar system permanently. Ongoing upgrades to NASA's deep space network are motivated in part by lessons learned from the Voyager program and will benefit the next generation of missions, such as the Artemis moon landings and future missions to outer solar system bodies. Voyager 1. It is not just a machine of metal and wires. It is a symbol of human curiosity, determination, and the desire to explore. As it moves silently through interstellar space, it reminds us that even in the darkest moments, the light of hope and intelligence can shine. And this legendary journey continues. The thrilling story of how Voyager 1 came back from the brink of death once again, and how human ingenuity is pushing the limits. For almost half a century, this old wolf has glided across the interstellar ocean, showing us once again what it means not to give up. Thank you for sharing this incredible journey with us. If you like this kind of space adventures, stories of humanity's eyes and ears in the farthest reaches of space, don't forget to like our video, subscribe to our channel, and ring that little notification bell. That way, you'll never miss the latest news and jaw-dropping stories from the edge of the solar system and beyond. We will continue to share the future adventures of Voyager and other space missions.